Now we're ready to create our first reducer. So here in the source folder, let's add a new file called reducer.js. As I told you before, a reducer is a function with two parameters, the current state and an action. The job of this reducer is to return the new state based on this action. So here's an example. If action.type equals bug added, then we want to return the new state. Now, earlier we decided to use a simple array to represent our store, an array of bugs. So if the user adds a bug, we want to return a new array. In this array, first we want to copy all the bugs in the current state. So here we're using the spread operator. And then we add a new bug object here. This object should have a few properties like ID, description, and result. So we set description to action, that payload, that description. And we set resolved to false. Now for the ID, we need to have some kind of counter. So I'm going to declare a variable here, last ID, and initialize it to 0. Now, every time we add a bug, we're going to increment last ID first and then use it as the value of the ID property. Now, there is something I want you to pay attention to here. The payload of the action should contain the minimum information we need to update our system. So in the case of adding a bug, we don't want to pass the ID or result properties because the minimum information we need for adding a bug is the description of the bug. So everything else should be computed here in the reducer because this is where we implement our business logic. Okay. Also, here I'm using the spread operator to copy this array. We don't have to do this. We can use one of the immutability libraries like immutable.js or immer. We'll use them later in the course. For now, I just want to show you the plain Redux code because that's what you see in most projects. So here's a case for adding a bug. So after our return statement, we can have else if action, the type equals bug removed. Now here we want to return a new array that contains all the bugs except the bug with the given ID. So I showed you how to do this in the last section. We basically get the existing array and filter it. So here we pass a function. We get a bug. We want to return all bugs except the bug with the given ID. We can pick that from action.payload.id. Simple as that. Now, what if the type of our action is neither of this? We should return the current state. This is very important because if we make a mistake, if we dispatch an action that doesn't exist, we don't want our system to blow up. We want to return the current state. Okay? We're almost done. The only part that is missing is the initial state. So when we start our application, the store is initially undefined. Redux is going to call our reducer and pass undefined as the value of the state. In that case, we want to return the initial state. We don't want to return undefined or null. Now, what is the initial state here? That is an empty array. So we can set that using a default argument over here. So when we start our application, Redux is going to call our reducer and pass undefined as the value of the state. In that case, we're going to reset the state to an empty array. Okay. Now, in this example, I'm using an if and else to implement this logic. We could also use a switch and case statement. Redux doesn't care. It's entirely up to you. Some people don't like switch and case. If you prefer if and else, go for it. But let me show you how to implement this logic using a switch and case. So we switch on action, the type. Here we're going to have two cases. One for bug added and another for bug removed. Now for each case, I'm going to copy the code from here. So here's our return statement, cut. I'm going to add it here. And finally for bug removed, we have another return statement. Very easy. We also need a default case if the action type is none of these values. In that case, we want to return the current state. So here's our final implementation. Now, one thing I need to emphasize here is that this reducer is a pure function. We talked about pure functions in the last section. A pure function is a function that, if we call it multiple times and give it the same arguments, it always returns the same result and is free of side effects. So in a pure function, we are not going to touch DOM elements. We're not going to work with any global state. We're not going to make API calls because all these operations can change the state of our system as a whole. In that case, if we call this pure function multiple times, we may not get the same result. So a pure function should be a small function in an isolated world. All it needs should be passed as arguments. These are the only dependencies of a pure function. So this reducer, this pure function, takes these two arguments and returns the new state. That's all it does. Now, these properties make it really easy to test this reducer. We don't have to set some global state before calling this function for testing. So in Redux, reducers have to be pure. Now, you might be wondering how we're going to make API calls. We'll talk about that later in the course. For now, don't worry about that.